Question number 22. Two blocks of masses m1 and m2 are connected by a spring of force constant K and are placed on a frictionless horizontal table, and the spring is stretched initially through a distance x0 and then released. The distance moved by the two blocks before coming to rest again for the first time is respectively. The first option your x0, second option is your m1 x0 by m1 plus m2, third option is your m2 x0 by m1 plus m2 and m1 x0 by m1 plus m2, fourth option x0 by 2 and x0 by 2. See the solution of this problem. It is given these are the two blocks. Initially the spring is at their natural length L0. Now when it is stretched, so mass m1 let displaced by x1 and this mass is somewhere here m2 let displaced by x2 and this total is your x0. The x0 is equal to your x1 plus x2, first equation. Since in a system there is no change in the, no external force is acting, whatever force is here kx0, same force on this also kx0, the external force on the system is your 0, the center of mass will remain same. So for same position of center of mass, for same position of center of mass, m1 x1 must be equal to your m2 x2. Now from equation 1 and 2 we can simplify. x1 is equal to your m2 by m1 plus m2 into x0 and x2 is equal to your m1 by m1 plus m2 into x0. So our correct option your option number 3. So hence answer number 3 is our correct option. Question number 23. From the top of a tower of height h, two identical stones each of mass m are thrown horizontally in opposite direction with equal speed. When they are at a height h by 2 above the ground, the velocity of their center of mass is first option root gh, second option under root 2gh, third option root gh by 2 and the fourth option 2 times root gh. Now the question is like this. They are saying this is your tower and the height of tower is your h. Now these are projected horizontally with the same velocity. Now when these are falling and when these two are at height h by 2, then we have to find velocity of their center of mass. So see, horizontal velocity will there remain same, but this and this are in opposite direction, so there is no change. So whatever the height it has fallen, vertical velocity Vy and this Vy, that we can calculate. So Vy square is your initial velocity 0 plus 2g h by 2. So Vy is your root gh. Both have velocity or root gh in the downward direction. So, velocity of center of mass along y direction m into Vy plus m into Vy by total mass your 2m, it is your Vy, and which is nothing equal to your root Gh. So, our correct option, your option number first is the correct answer. Question number 24. A balloon of mass 150 kg is floating in mid-air when a person of mass 50 kg is standing on the rope ladder which is suspended from the balloon, and the person is at a height 20 meters from the ground. If the person climbs up the ladder to a height 4 meters, the final height of the person from the ground is first option your 21 meter, second option 22 meter, third option 23 meter, and the fourth option 24 meter. Now see the solution of this. Question is that this is the lead balloon and here this is a ladder. These are the ladders and this is the ground here, and this is the lead position of a person. Right now person is 20 meters from the ground. Now the mass of the balloon is given 150 kg while the mass of person is given 50 kg. Now the person climbs 4 meters on the ladder. So when the person is moving 4 meters on the ladder, that balloon comes down at distance here y. Since system is in equilibrium, no external force is there, the center of mass of the system will remain your same. So, change in the position of the system. So, the distance raised by the person up your 50 into 4 must be equal to your 150 minus y. So, delta ycm is equal to your 0. So, delta ycm, person is moving upward 50 into 4, balloon is coming down 150 into y. So, from here we can get the y is your 200 by 150 in a 4 by 3 meter. Y is your 4 by 3 meter. It means if the man is moving up 4, so balloon will come down by 4 by 3 meter. So, displacement, the position of man from ground, position of man from ground, that is your 20 plus 4 minus 4 by 3. So, 24 minus 4 by 3 is 68 by 3 meter, or so this is the answer here. Answer number 3 which is given here 68 by 3. So, correct answer your option number 3. Question number 25. A particle of mass 0.1 kg moving with an initial velocity v collides with another particle of same mass kept initially at rest. If the total energy becomes 0.2 joule after the collision, then the minimum and maximum values of v are. One option here 2 meter per second, 4 meter per second. Second option 2 meter per second and 2 root 2 meter per second. Third option 2 root 2 meter per second and 4 meter per second. And the fourth option here 2 root 2 meter per second and 4 root 2 meter per second. So, they are asking minimum and maximum value of v. So, it is given here they are one particle of mass 0.1 kg moving with velocity v, and it collide with another particle of same mass 0.1, but initially it is your at rest. So, if the total energy becomes 0.2 joule after the collision, energy becomes 0.2 joule. So, minimum and maximum here, there are two conditions here. In case of maximum energy, that maybe you can say energy due to the elastic collision, and another your inelastic collision. So, first elastic collision. Elastic collision, the velocity will interchange, the half m v square is equal to 0.2 and m is your 0.1. So, v square is equal to your 4. So, v maximum is your 2 meter per second. This is the maximum velocity here. Now, second one, inelastic collision. Inelastic collision, both will move together. So, mv is equal to 2m into v dash. So, v dash is equal to your v by 2, which is v by 2. So, now kinetic energy, now energy is equal to your half 2m into v by 2 whole square, and this is velocity given here 0.2 joule, which can be written as here mv square by 4. M is your 0.1. The v square is equal to your 8. The v is equal to your 2 root 2 meter per second. So, here we can say velocity maximum your 2 root 2 meter per second and minimum velocity is your 2 meter per second. So, our correct option your option number 2. So, hence answer your 2 is the correct option. Minimum velocity 2 and maximum velocity your 2 root 2 meter per second. Question number 26. The two blocks of masses 5 kg and 2 kg are placed on a frictionless surface and connected with a spring as shown. An external impulse given a velocity of 14 meter per second to a heavier block in the direction of lighter one. So, just after the impulse, the first option is your velocity of center of mass is 10 meter per second. Velocity of 5 kg block with respect to center of mass is 4 meter per second. Third option, velocity of 2 kg block with respect to the center of mass is minus 10 meter per second. And the fourth option, your linear momentum of each body about the center of mass is equal in magnitude but opposite in direction. Now, we have to select the correct option. So, question is like this, we are having two blocks, one block of mass 5 kg and another block mass 2 kg. This is your 5 kg block and this is 2 kg block, and here impulse, it is given an impulse of 14, impulse is given so that the velocity of 14 meter per second. Because of this impulse, it has acquired velocity 14 meter per second. Now, just after collision, velocity of center of mass here m1 v1, here it remains 0, m2 v2 by m1 plus m2. m1 v1 14 into 5 plus 0, m1 plus m2 is 7. That is your 10 meter per second. This is the velocity of center of mass. So, first option you are correct. So, first is correct. Now, velocity of 5 kg block with respect to center of mass, velocity of 5 with respect to ground minus velocity of center of mass with respect to ground. Velocity of 5 with respect to ground your 14, while center of mass 10. So, this is your 4 meter per second. Our second option is also correct. Now, velocity of 2 kg block with respect to center of mass, velocity of 2 with respect to ground minus velocity of center of mass with respect to ground, which is 0 minus 10. So, minus 10 meter per second. Our third option is also correct. Now, linear momentum of each body. Since if we are considering both the block as a system, and in this system there is no external force is acting, so the momentum of the system will remain your constant or remain 0. So, whatever the momentum of this, same momentum of this, but in the opposite direction. So, our fourth option are correct. So, our correct options are 1, 2, 3 and 4. All are the correct option. Hence, answer is your 1, 2, 3 and 4. Now, question number 27. The two particles of equal mass are projected simultaneously into the vertical plane from the roof of a tower of height 20 meter with the same speed 20 meter per second, one horizontally and the other vertically upward. Now, the four options are given. Option number 1, the acceleration of center of mass of the two particles is g by 2 downwards. Second option, acceleration of center of mass of the two particles is g downward. Third option, maximum height of the center of mass of the two particles from the ground is 25 meter. And the fourth option, your maximum height of the center of mass of the two particles from the ground is 40 meter. Now, see how to solve this problem. So, question is given like, now this is a tower of height 20 meter. We can say, let our coordinate system is this x and y. One particle projected horizontally, another you are projected vertically with same speed 20 meter per second. With same speed 20 meter per second. So, now they are asking acceleration of center of mass. First of all, ACM is equal to your m1a1 plus m2a2 by m1 plus m2. Both the particles have equal masses and both are coming under the gravity downward. Both are moving under gravity downward. So, minus mg by 2m, so that is your minus g. So, acceleration of center of mass is g downward. So, option 1 is your wrong, option 2 is the correct. So, one option your option 2. Now, next we can get the velocity of our vertical velocity of center of mass VCM in the y direction, m1 y1, m1 v1, m2 v2 along y by m1 plus m2. First have velocity of 20 up, so 20 into m plus this have 0 and m1 plus m2 your 2m. So, VCM in y direction is your 10. So, now it is going under gravity g. So further distance travel, the v square final 0, 10 square minus 2, g is your 10. That further height raised by center of mass is your h. So h will be your 5 meter. So further center of mass go up to the height h. H is your 5 meter, and initial height of the tower is given 20 meter. So total height, so height raised by the center of mass from the ground, height reached by the center of mass from ground is your 20 plus 5, 25 meter. So option number 3rd is the given option. So overall answer is your second and third options are correct option, option number 2 and 3. The question number 28, center of mass of 3 particles of masses 1 kg, 2 kg and 3 kg lies at the point 1, 2, 3, and center of mass of another system of particles 3 kg and 2 kg lie at a point -1, 3 and -2. Where should we put a particle of mass 5 kg so that the center of mass of the entire system lie at the center of mass of the system? So option number 1 is your 0, 0, 0. Option number 2 is 1, 3, 2. Option number 3 is -1, 2 and 3. Option number 4 is your 3, 1, 2. So as per the given question here, there are 2, 1, 2 and 3 kg. The center of mass here 1, 2, 3. The total mass here m1, yani 1 plus 2 plus 3. Their center of mass here 1, 2, 3. And second mass here m2, which is here 2 kg and 3 kg. The 2 plus 3, and their center of mass here -1, 3 and -2. -1, 3 and -2, and they are asking where should be third mass m3, 5 kg should be placed so that the center of mass of the system coincide with this. So x, y, z is equal to your, we can say m1x. So m1 means 3 plus 2, 5 plus 1, 6. 6 into 1. Similarly, -2 plus 5x. This is your x coordinate by total mass 10 plus 6, 16. Similarly, y coordinate, check it from y. 6 into 2, 12. 5 into 3, 15. 5 into y, 5y by 16. And third one is your z. 3 into 3, 9. 3 into -2, -6. So 3 and 5 into z, 5z. So 3 plus 5z by 16. These are all equal. X is equal to your 6 minus 2, 4 plus 5x by 16. Similarly, y is equal to your 12 plus 15, 27 plus 5y by 16, and z is equal to your 3 plus 5z by 16. From here we are getting 16x is equal to 4 plus 5x. So that will give you 11x is equal to your 4. This give you 11y is your 27, and z give you 16z minus 5z. So 3 by 11z is equal to 3. So from here we can have x is equal to your 4 by 11, y is your 27 by 11, and z is equal to your 3 by 11. So this is the option, and the answer is your fourth option is the correct option. Question number 29. Question is this: the adjacent figure shows an infinite frame of two sides in a gravity-free space. What is the final constant kinetic energy expected of the ball of mass m projected as shown with an initial velocity v0? The coefficient of restitution for the collision between the ball and the frame is 0.5. So final velocity they are asking after the collision. So as per the question here, these are the two infinite ball and a particle has been projected making an angle theta. This is the particle making angle theta with velocity v. So when the particle strikes to this, at this time after the collision, so initially we can see this direction have velocity or v sin theta, and this have velocity or v cos theta. As the velocity of the particle here after collision changes, since after collision here velocity along the impact, along the line of plane, velocity will remain same, but this velocity will change, that become your, let here your v1, ev1, then again here velocity that remains same, this velocity will change. So this is your ev1, let v2, it become your ev2 like that. So finally final velocity we can say net velocity, final velocity or u v cos theta, that will be your in the, you can say j direction, plus after n collision, so as we are getting e to the power n into v sin theta. This is the final velocity we are getting, that you are in I direction. So this is the final velocity. So in this way what we are getting, the collision, n is the number of collision and it will continue up to infinity. So since n goes to infinity, so net velocity will remain only v cos theta. So kinetic energy we can calculate. So kinetic energy is equal to half m v cos theta square, 0.5 m v square and cos square theta. So our correct answer here, answer number 3. Now question number 30. Question is this: a spherical hollow is made in a lead sphere of radius r such that its surface touches the outside surface of lead sphere and passes to the center. What is the shift in the center of mass of the lead sphere due to the hollowing? First option is your r by 7, second option your r by 14 and third option your r by 2, while the fourth option is r. The question is like this: a sphere is given and it had radius r. From this sphere, a cavity has been made. To find the shift in the center of mass of the system. So, only need xcm is your mx minus m into x by m minus m, where m is the mass of the whole sphere without cavity. So, m can be written as rho into 4 by 3 pi r cube, while small m your rho into 4 by 3 pi r by 2 cube, that is nothing, m by 8. See, mx, this was at the original center 0, m your m by 8, x is your distance here r by 2, m minus m by 8. So, this will be your minus mr by 16 by 7 m by 8. So, m by 8 and m by 8 cancel. So, it will left over minus r by 14. It means center of mass will shift by distance r by 14 left side of the original center. So, our option number 2 is the correct. So, hence second option is the correct option. Question number 31. Question is this: a carpenter has constructed a toy as shown in the figure. If the density of the material of the sphere is 12 times that of the cone, the position of the center of mass of the toy is given by. First option, add a distance of 2r from O. Second is your add a distance of 3r from O. Third is add a distance 4r from O. And fourth option, add distance 5r from O. So, first thing, see the diagram of a toy made by a carpenter. So, he has made one sphere and this is a cone, and this is the point, can be said as O. Center of mass of this here O1, which is at a height h by 4, and center of mass of this is your at O2, and total height of this is given as per the diagram. It is given your 4r and this is 2r and this is r. And one more point here given, the density of the material of sphere is 12 times the density of the cone. The density of this here let rho, and this density will be your 12 rho. Only y coordinate is needed. So, ycm is equal to your m1 y1. M1 here, this is total height to your 4r, so 4 by r. M1 is your rho into 1 by 3 pi r square, h is your 4r. This is your M1 into center of mass, that is your r, plus density here 12r, 12 rho, volume 4 by 3 pi r cube, and position of center of mass from here to here, this is 4r plus r, 5r, divided by total mass density 1 by 3 pi r square into 4r plus 12 into 4 by 3 pi r cube. Now, we can simplify. So, this is your 4r to the power 4, so 4 by 3 pi r to the power 4 plus, and this is your 240 by 3 pi r to the power 4 by This is your 4 by 3 pi r cube and plus, and this is your 48 by 3 pi r cube. Now simplify further. So 4 by 3 can cancel from all over, or here 240 plus 4, 244 pi r to the power 4 by 48 plus 4, 52 pi r cube. So finally we can have 244 by 52 r, and now simplify this. This will be, we can divide by 4, 61 by 13 into r, and this is approximately, or directly we can say 61 by 61 r by 13. So our correct option, your third option is the correct option.